In this video, I want to show you guys how to create a function that will return all possible permutations of any given string. And for those of you that don't know what a permutation is, essentially what this function is going to do is it's going to return all possible arrangements of any string that we give to this function as input. So for example, if we have the string A and we save this this project, all possible permutations of or arrangements of the string A is A. And if we said ABC and we save this and ran it, as you can see, all possible permutations of the string ABC is ABC, BAC, BCA, ACB, CAB, and CBA. So that's just going to be a brief introduction to what we're going to do in this video. Next, we're going to actually code this out, and I'm going to explain it to you, and then I'm going to further explain it to you on the chalkboard, and we're going to draw it out and show you how all this recursion works and try to make this complicated idea a little less complicated. So in the coding portion of this video, we're going to start by creating our function, and it needs to take in a string as input. And this string will be the string we find all possible permutations of. So we're going to say use the define keyword, call this function permutations. Input will be word. And then if the length of the string is just one character, well, all possible permutations is just that character. So if length of word is equal to 1, we're just going to return, we're going to make it a list, so we're going to return that character as a list. Okay, now we have to create the logic for the strings with lengths greater than 1. Okay, so what we're going to do is we're going to start out with our recursive section of this function. So we're just going to say perms is equal to permutations word 1. Okay, this is a recursive call that gets all possible permutations of length n minus 1. Okay, so now we are going to create a variable called char, and it's going to store the very first letter in our word. So we're just going to say word 0. Now we need to create a list that will contain all possible permutations, and for now it's just going to be empty. So we're just going to say result is equal to empty list, and then we need to iterate through our list of all permutations of length n minus 1. So we're just going to say for perm n perms. And then we need to iterate through the characters of each individual permutation in our list. So we're going to set a second for loop within our first for loop. We're going to say for I in range of length perm plus 1. Okay? So from here, what we need to do is we're going to now take our char variable, which is the first letter of our word, and place it at the beginning, middle, and end of every permutation in our perms variable. We are then going to append it to our results list. So it's going to look like this. It's going to say result dot append perm I plus our character plus perm I. And what this is going to do is it's going to take any given letter. So say we have ABC, it's going to, or say we have BC, it's going to take, and say we have the letter A as our char variable, it's going to place A here as one permutation, and then it's going to place A here as the second permutation, and then it's going to place A here as the third permutation. All it's going to do is it's going to put the character in every possible position in that word that it can be, okay? That's what that's going to do. And then all we need to do is return the result. So we are going to say, on our outer for loop, return result. And if we ran this, so we're going to have to save it and then run it. Oh yeah, we have to call it duh. So we're going to say print permutations, and then we're just going to say ABC. And then if we save this, yeah, so ABC, BAC, BCA, ACB, CAB, and CBA. And if you didn't already know, the amount of permutations that there will be is found out by n factorial, okay? So if there's 3 letters, which we're trying to find out all possible permutations, the amount of permutations that there will be is 3 factorial, which is 3 times 2 times 1, which is 6. So if you count these, this is 6. It gets large really fast. So say we did DE and we save this. As you can see, it's gotten quite large, and I actually have to scroll for you to see all that. So before you just go type in a 20 letter string to find all possible permutations, I advise you to not do so. Okay, it gets large really fast. Okay, so in the next section of this video, I'm actually going to dissect this and explain it in fully on the chalkboard. Okay, so I will see you guys in that section. So for this section of the video, we're going to walk through step by step on what this function does. So it all starts here with the call to the permutations function with the input ABC. And so the first function call, and it passes the input ABC up to here, up to this part of the problem. Okay, so word will be ABC for this function call. Word is equal to the string ABC. Okay, so then it checks if the length of the word is equal to 1, which it isn't, it's actually equal to 3. So it goes down here to perms is equal to permutations, word from index 1 all the way to the end. So index 1 is the second character. So this creates another function call right here, but of length n minus 1. So it's going to create another function call of permutations with string BC. So we are going to say this is the second function call, but it's also the first recursive call. Okay, we're gonna underline this. That was a terrible underline. Okay, so it's going to pass word BC, so the word for this function call is going to be equal to BC, and then it's going to check if the length of the word is equal to 1. It's not, so it goes back down to the perms variable, and it's another recursive function call of length n minus 1. So it calls permutations with the character C, so it goes up here, and the third function call, the second recursive call, is now done. And I'm going to try to create a better line. Okay, so it's passing the character C to the word. So for this function call, word is equal to the string C. Okay, so as you can see through here, we're actually creating a stack. This is called a stack. It's called a call stack. Okay, and just keep that in mind. So then it goes down into the function. If the length of the word is equal to 1, well, our word for this function call is the character C. So it is equal to 1. So it goes down into here and it returns the word. So our word is C. And what happens here is it returns it to this function down here. But where it goes is actually equal to perms. So now perms for our second function call is actually equal to C. So perms is equal to, don't forget it's a list because we created it into a list. So perms is equal to the list of the string C. And this part of the stack now gets removed from this call stack. So this very top layer gets removed and it just disappears. So now we just have the second function call that we have to deal with, and word is BC. So it has returned it to here, and now we go downwards throughout the flow of our program. So character is equal to word of 0. Well, our word for our second function call is BC. Okay, so word of 0 is B. So now character is equal to the string B. Okay. Result is an empty string, or result is an empty list. So for perm and perms, well, what is perms? If we look over here, perms is the list C. So what this would do is this would iterate through every item in our list, or every element in our list, and then it would iterate through with our second for loop throughout every character in every item. But since there's only one element in our list, it's just going to be iterating through C. So for perm and perms, for I in range of for I in range of the length of perm plus 1, perm is just the length is just 1. So this is going to be equal to 1 plus 1, which is 2. So for I in range of length of 2, well, if you didn't know, the range function, when you say the range of 2, it goes up 2 but not including 2. So it goes 0, 1. So this would be range of 0, 1. And then result dot append perm from the very beginning to I, which would be I is 0. So from of perm 0 plus the character, which is B, so we'll just put B, plus perm I, which is 0, so perm 0 all the way to the end. And if we wrote this out, perm from the very beginning to the 0th element is nothing, so that's not going to return anything, plus our character B, so this is going to be B, plus perm of 0. So from the very beginning to the very end. Well, perm, if we look, is just C. So it just appends B, C, and it appends it to our result list. So our result is now equal to B, C. But you can't forget, we've only done this one. So now we have one more we have to go through. And it's 1. So we do the same thing. Perm of, so we go back up here, and then we go to perm of from the very beginning to the index 1, which is the very first character in our perm list, so that would be C, and then plus the character B, plus perm of the very, or perm of from the very index number 1 to the end. Well, index number 1 doesn't exist because this is index number 0. Okay, so that's index number 0. So it doesn't exist for that. So result is equal to the list, which contains 2 strings. One is B, C, and the other one is CB. Okay, so then it goes down and returns result, and it returns it to this first function call. So as before, it removes this call function off the top of our stack, and it goes down here. Okay, so now what perms is equal to, and it shoots perms down to this function call. So perms was not perms. So when it returns our result of BC to CB, it returns it to the first function call, and where it returns it to is to this perms variable right here. So now perms is equal to the list of B, C, and C, B. Okay, so now it does the same thing. It walks from here downwards, right? So for perm and perms, so perms is BC and BC, so it's going to iterate through our 2-element list. So our first one is going to be iterating through BC, and then for I in range of length of perm plus 1, well, the length of our first element is 2, so this is going to be 2 plus 1, which is going to be equal to 3. So this is going to be for I in range of 3, which is 0, 1, 2. Because remember, it goes up 2, but not including the actual character that you type in, or the actual number you type in, and it starts from 0. So it does this same thing down here, right? And what it's essentially going to do is it's going to take this result, and it's going to because it's now our perms right here, it's going to add the character A, because our word character is now, as you can see, our word is A, B, C. Word of 0 is actually A, so our character is going to be equal to A. And what it's going to do is it's going to take perms, and for each one of these it's going to put A. So we have BC, so let's just draw a line. We have BC for our first for loop, and then it goes in here and it checks. It goes 0, 1, 2, 3, right? So what it's going to do is it's going to append A 3 times. It's going to append A once here, once here, and once here. And what it's going to look like is A, B, C, B, A, C, and then C, A, B. Okay, and then it's going to go to our second one, which is CB, and then it's going to do the same thing, because there's 3 different times it's got to append A. So it's going to be CB, so CB is going to have A appended here, here, and here. And what it's going to look like is ACB, CAB, and then CBA. Okay, and then what it's going to do is it's going to return result, and that's our last function call. It returns result, and then it prints it out to the screen. It returns it back to here, our print function, and then our print function prints it out to the screen. And that's essentially how this program works.